Hello, ngHouston. So tonight we're live. Thank you, Dan. Thank you. We're live at Improving, but we have a remote guest, so it's going to be kind of tricky, but I think it's going to be cool because the topic tonight and the guest tonight is actually, I've been trying to get this guest on the show for like almost a year, and finally our calendars lined up, so I'm pretty excited about that. So we're going to make it work, and it's going to be a pretty cool topic. But first, we have we have people here, and we also have online panelists, so we should have a pretty good bunch of questions. And so we're going to introduce the panelists first, and then we'll introduce our speaker, and you guys know the drill. So actually, I'm going to go with Brocky first because he's our in-house heckler. So Brocky, you want to say hello?
Hi, Houston and Internet. And I don't just heckle. I also ask bad questions.
Yeah. Okay, and I'm going right to left here today to confuse myself. So Lance, you want to say hello and tell us who you are? We know who you are, but just for anybody who hasn't watched before.
Hello, I've been a panelist a few times. My name's Lance Finney. I'm an instructor with Angular Bootcamp, but most of the time I'm a developer with Oasis Digital in St. Louis.
And you never know when a random cat is going to walk across Lance's camera, but they're cool.
Yeah, she's over on the printer right now. She might come back.
And we have Keith, but he's actually muted because he's right here behind me. So,
hi, I'm Keith. I'm a co-organizer of ngHouston now.
He's awesome. And we also have Denny off camera, who's also a co-organizer of ngHouston. And they keep me sane, which I love. I should have recruited them a long time ago. And next we have Justin. Justin, I'm always happy to have you. I'm tickled when you show up. I wish you were here every week. You want to say hi?
Hi, thanks. Yeah, I could virtually be here every week, so maybe that could happen, right?
Well,
I'm here to bring.
You're always invited.
I'm here to bring balance to the force, to balance out Mike's heckling. I'm gonna submit all the love today, so that's what I'm gonna do.
That's awesome. So we have the bad panelist and the good panelist. Lance, I'm not sure yet where you fit into that, but we'll figure it out.
All right, sounds good.
Okay, so last but not least, without further ado, I'm super excited to introduce James Henry. James, say hello.
Hey everybody, thanks very much for having me. Yeah, it's been a while in the works, but we made it happen together, so I'm really happy. And I'm really, really happy that the guys managed to join the panel as well. That was a nice surprise.
They're so fun. And just so we know, so we had this mix-up last week on Angular Air, but it's Mr. Justin asked why I keep calling you Mr. James Henry, because that's your Twitter handle. So if you want to follow James on Twitter, it's Mr. James Henry. MR, though, don't spell it out. MR, James Henry.
Yeah.
Cool.
Unfortunately, somebody is squatting on James Henry. It's not somebody called James Henry. Somebody just has had the account for a long time. So I'm stuck with Mr. James Henry.
That's okay. I think it's very sophisticated. I like it.
It's not inaccurate, but it's, yeah.
Okay, so you want to go ahead and jump in, and you can share your screen and teach us something cool.
Let's do it. I'm going to immediately ask for feedback. What's my zoom level like? Shall I zoom in a bit more?
Yes, you shall.
Okay. I'm all ready for zooming. Look how prepared I am. By a massive increase. Is that better?
What do you guys think? A little more?
That's good for me.
Yeah, we can see.
Okay. Good. So I've got my little agenda in Markdown here. So the idea of the talk is we're not focusing on anything outside of the standard Angular stack. We're talking about the Angular CLI, and we're talking about TypeScript. No specific versions of either of those two projects. I'm just starting with the latest Angular CLI here. So we're making use of the latest and greatest, but what I'm talking about will apply to any project that's using these two tools, TypeScript and the Angular CLI. So just very briefly up front, as well as being Mr. James Henry on Twitter, which Bonnie kindly reminded me to add to my agenda. As you might hear from my voice, I'm from the UK, but I moved to Canada about 6 weeks ago. So I'm on a 2-year work permit here. Really, really excited. I live in Toronto now. And I work for Null with Justin, and Victor, our CTO, is here, Victor Savkin. So I live, as he described it, uncomfortably close to him, because his building is literally that one right there. But what are you going to do? You live in the cool area, you're going to get me next to you. That's what happens. So I absolutely love TypeScript, as you might be able to tell, and I love Angular. At Narwhal, we try and improve everybody's experience of using Angular and getting the most out of it. And obviously, TypeScript plays a major role in that. My interest in TypeScript goes back a number of years, and I contribute to all kinds of open source projects which have something to do with TypeScript. So for example, I built a TypeScript parser for ESLint, which then it turned out had general applicability to many other tools in the JavaScript ecosystem. So it's what powers Pretty's TypeScript parsing and the formatting that's in there, which I'm making use of in here. And Babel, the TypeScript team, have dedicated some resourcing to parsing TypeScript in Babel natively. So I partnered up with them on that. And I've also produced about 10 hours of TypeScript courses. And I very inventively put those on TypeScriptCourses.com. So you can check those out if you want. First one's free. Second one's got a discount on. So yeah, I'm a Microsoft MVP for TypeScript from that work. So it's a major part of what I do.
That's pretty impressive, James. I'm going to have to start being nicer to you.
It's like scout badges. I try and collect them and stitch them onto my shoulder. Cool. So yeah, the one thing I want to start with is this is just an Angular CLI project. There's nothing special. I haven't done anything here apart from add a prettier config file so that I don't need to worry about formatting as I'm typing. And the first thing I wanted to do was just look at what we get out of the box. Because obviously, we don't have to do anything with our TypeScript setup to get the Angular CLI to work. The Angular CLI is an amazing project. Everybody should be using it. And it is meant to be low barrier to entry. So that means, in some cases, not taking full advantage of the stricter, more powerful type checking that TypeScript can offer us, because it is a bit more overhead for the user to get to grips with some of the extra syntax, some of those extra concepts. So it makes perfect sense that the Angular CLI doesn't turn these on out of the box, but it's really powerful if we as users can understand these different features, because then we can turn them on ourselves, we can opt into them and get the real benefit from them. So that's what we're going to look at in today's session. So out of the box, we get a tsconfig.json file at the root. And this is important because tsconfig.json files are the configuration file for the TypeScript compiler. The TypeScript compiler is ultimately what runs behind the scenes to transpile our code and type check our code. The concept of the Angular compiler is just a wrapper around the TypeScript compiler, but ultimately it's the TypeScript compiler that powers everything. So our tsconfig.json is a critical piece of configuration for our projects for the Angular CLI. tsconfig.json files can be inherited from. So inside of our source, inside of our app in here, we have a tsconfig.app.json. There's no special significance about .app.json or .spec.json. They don't have any semantic meaning. It's just a convention that the CLI goes for to make it clear that this is dealing with processing your source code, and this is dealing with your test code. So the tsconfig.app.json, you can see it's making use of the extends property here to extend our base tsconfig.json. So that's just highlighting that you can compose these tsconfig.json files together, so you don't have to keep repeating the same options over and over again. You can just tweak a couple of them at a time if you need to. The root one is also very important because it powers a lot of the tooling that you are used to and make good use of in your projects. So for example, VS Code is built with TypeScript, so it makes heavy use of the TypeScript language service behind the scenes. So if I open up a file, I'm going to be working on it, it's going to give me code completion and the syntax and all of the different methods and interfaces and all that kind of stuff, because a language server is running behind the scenes. And ultimately, that language server is going to be using our tsconfig.json as a reference point if one is available. So specifically, the options that are turned on, we're just going to be specifying that we have our code being written to an out dir, which means that we're not going to be transpiling test.js and have test.ts and have test.js next to it. By default, the TypeScript compiler will just output the JavaScript version of the file next to the TypeScript source, which is almost always not desirable. So you'll see out dir in almost every TypeScript project you see configured. And you can see we've got source maps enabled. This is all inside of a thing called the compiler options. And this will be the focus of the session that we're looking at today. These kind of options in here, a lot of them are quite self-explanatory. These are what we'll be looking at, unlike, for example, additional options around what do we include in our compilation. So outside of compiler options and extends, we have files, exclude, include, and some additional ones, which we need in projects, but it's not going to be something we're going to be looking at today. Cool. So with this configuration, so we're targeting ES5. We've got some specific type information we're bringing in specifically for our compilation, and we're making use of decorators because we're in an Angular project. We can write code potentially which looks like this. So I have a component here called hello component. There's nothing crazy about this. As you can see in my code here, there's no red squiggly lines anywhere. Like, you might have spotted some things which look a bit odd, but fundamentally, this is valid code as far as TypeScript is concerned, based on its configuration that it comes with out of the box with the Angular CLI. So that means in any project which starts with the Angular CLI and doesn't change the tsconfig.json, this would be a valid file. It would pass type checking. So what we're going to look at today is how we can get TypeScript without needing to change anything about the CLI to up its strictness and pick up on some issues which do actually exist in this project and cover some of the different features that they offer inside of Strictmode, as it's called. So that's what we'll be looking at in a second. That was me cheekily reminding myself of what's to come. So as you can see here, we've got this fairly unusual thing of using this outside of any kind of functional scope. So this in JavaScript, if you're not in strict mode, will keep bubbling up until it gets assigned to the global object. And in a browser context, the global object is the window. In a node context, it's a special global. But in the browser, this becomes the window. So we are just randomly assigning a property on the window object called foo to equal true. This is perfectly valid JavaScript outside of strict mode. And we'll look in a second why we're not actually running in strict mode for this TypeScript compilation. We have name as our only property here on our components. It's going to be a string. One thing to note, we haven't initialized this to any particular string. We've just said name should be a string. This is perfectly valid in the current setup. Inside of our ng on init as our lifecycle hook, we're doing some DOM manipulation directly. This is not very semantic or like very best practice-y Angular code, but is perfectly valid code. And there may be advanced use cases where you need to touch the DOM directly. So it's not uncommon to see this in Angular projects, but it's definitely not uncommon to see this in TypeScript projects. So it's definitely worth understanding. And this provides quite a good example of a couple of different flags that I want to show. And then finally, I have this method, which is very easy to understand. It takes in 2 arguments and adds them together. So right now, we have no type issues whatsoever. We can even prove this directly. Obviously, I said that the TypeScript compiler is powering all of this behind the scenes. So we could execute the TypeScript compiler directly if we wanted to and run it as just a type checker on our project to test the whole thing at the same time for any type errors. So we can make use of the no emit option for the TypeScript compiler to just run it as a type checker. It won't transpile the output and write it to disk. It will just run its type checking processes. TSC is the name of the executable script that we've got from the TypeScript compiler. We could reference this by going node modules bin TSC. That's where it lives inside of our project. This is where the TSC ends up being written to. But we can also make use of the more modern feature in npx, which comes bundled with it, which allows us to just run the name of the binary, and then it will look it up. So it'll run it for us. So that's just a handy random tip, which has nothing to do with anything I'm saying.
Hey, James.
Yeah.
I have a quick question. So you mentioned that the tsconfig is the file that the TypeScript compiler uses to find its options.
Yeah.
But you also touched on the tsconfig app.json. So when you run this command and you're running TSC directly, which configuration files that actually pulling from?
So this would pull from the closest one it can find. So in this case, it would look at the root, as far as I understand. So because I haven't gone into that directory and because I haven't referenced this tsconfig.app.json, it will prefer just a tsconfig.json if one's available.
Okay, so it's not using any of the options that are defined inside the app or spec JSON file in that directory.
No. That's a good point, but it's not just for the thing I'm highlighting. It shouldn't be relevant just at this point, but it's definitely a good point to make. You do have the option to pass a flag P or project, I think is the full name of the flag. And that's the way that you would specify the path to the tsconfig.json that you want to reference. But by
Hey,
default,
James, I have a question too. But my question's better than Brocky's question. I'm just kidding. I love you, Brocky. So I know you probably just said this, but I missed it. Where did NPX come from?
So NPX is a new helper tool which comes bundled with npm. So if you're on npm, I think version 5 and above, you just have it on your machine. It's already there. It's just a global command you can run. So basically, what it will do is, by default, you've got it locally installed, and it will run it there. If it can't find it there, it will try. I think it will try and run your global version of it. And if you don't even have a global version of it, it will actually install it behind the scenes in the background, execute it, and then clean up after itself. So for I think one famous case of where it's really useful is for things like create React app. Like things you globally install, but then pretty much run once in a blue moon. Like you don't need it ongoing in your project. It's a perfect tool for that because you don't have to worry about doing, because normally you'd have to do npm install global create React app, then execute it, and then you've just got it on your machine. It gets out of date, etc. So it was designed for that use case in mind. But because of its resolution algorithm, I guess you could describe it as, because of the fact it looks at your local node modules first, it's a useful thing to use if you ever need to execute something which lives in your node modules directly without having to build up the path manually yourself, like that. Just a shortcut. Slightly fewer characters, no slashes. That make sense? I'm afraid I can't see anybody, so.
Yes, it makes total sense.
Okay, it's very disconcerting, but I can't see anybody. I can only see the shared.
I was nodding, but they keep making me turn off my microphone because it makes an echo. So.
Cool. Yeah. So running that command, so running the type checker on our project, we can see, as we would think, we don't have any type errors because. We would have seen, right now, this project is so basic. I've only got default Angular CLI stuff, and I've changed this hello component to have some extra stuff, and there's no errors in the component. So this is what we would expect. No errors are being emitted. So we're in a good position. We have a working project, and we are now in a position where we can think, is there any more we can do? Is there any more power of TypeScript we can add to our project? And the key thing that we're going to look at today is Strictmode, and particularly the strict true compiler option. So inside of compiler options, if you're using VS Code, it actually gives you completion on all of the different compiler options if you start typing inside of the JSON. So you can see here we've got strict here, and it's a Boolean, so we're saying it's either true or false. By default, it's false. So this is exactly the same setup as if we had left off the option completely. Whoops, what am I doing? Importantly, though, if we set it to true, what strict actually is it's a shorthand for a few other flags that exist inside of our compiler options. So back to my agenda here, I've listed out the ones we're going to discuss today. When we set strict to true, we're going to be setting always strict to true, no implicit any to true, no implicit this to true, strict null checks to true, and strict property initialization to true. One of the cool things about having this single flag, which is basically a layer in front of these other flags, is it means that you can both set and forget, and whenever new versions of TypeScript come out which introduce new strict checks, you just get them automatically. Obviously, this could break your code, but arguably this is a good thing because it shows type issues you had already which you weren't able to pick up on. And also, it means that we can fine-tune what options we get without having to type out every single option manually. So that's something that we'll talk about right at the end of this, is how can we avoid issues with turning on strict mode and just having thousands of issues across a giant project, for example. That's something we'll cover right at the end. But for now, we're just going to look at each flag in turn and how it's relevant to the code I've already written in here, which, according to TypeScript right now, is absolutely fine. So as simple as that, I'm going to turn on true, strict mode true, and we're going to go back to our hello component. And sometimes in Visual Studio Code, if you change a core TypeScript option, you might need to restart the. Oh, it actually happened while I was talking. Normally, I wouldn't be talking, so I would manually reload the project. There's an option in VS Code to reload your project, so that will restart the process which is concerned with giving you that feedback. So you can always run that. If that doesn't work, you can always reload the window in case you're expecting to see changes. But in this case, while I was talking, it restarted itself. So you can see now, it turns out we have a ton of issues in this file. Surprise. It's almost like I planned it. And we're going to look at each of those issues and how they relate to what we have now enabled inside of our project. So the very first one, which is the unusual case, but not impossible and not unreasonable case of this.foo, and this meaning the window object. So as I mentioned, this has something to do with Strictmode in JavaScript, not just in TypeScript. One of the things that the strict true option has done is it sets the option always strict to true. So this means two things. This means that we're going to be running in strict mode in JavaScript. So effectively, it's the same as if we'd gone use strict true at the top of our file. You may or may not be familiar with this from writing JavaScript. This allows us to opt into strict mode. So it's the same thing as if we'd done that. The TypeScript compiler is effectively going to be considering that to be strict mode. And the other thing it's going to do is when it generates our JavaScript code at the end of the process, when it writes that to disk, it will have use strict in all of the output now. Before, it wouldn't have the use strict pragma in there. And so this will opt our runtime code into strict mode as well. So this.foo is now not going to be the right thing for us to do. We have a number of other issues in the file, and I put them in a rough order, so no implicit any is quite an easy one to deal with. So we're going to actually go down to our add method here to talk about no implicit any. So right now, where we have this add method, TypeScript inference, the process of inferring the type of something by how we've written our code, is actually really, really good. And it's got better and better, particularly over the last couple of years since the TypeScript team's been working in close collaboration with the Angular project, for example. They've got so much amazing feedback from people that they've been able to improve common cases and infer things. So when I write code like const foo equals string of nar, fine, nar is fine. Not only will it infer that nar is a string, it will actually infer that because it's a const, it's the string literal nar, because I can't be reassigning a const. It must literally always be the type string of nar, not just any string, because I can't reassign foo to something else. I can't type and talk at the same time. TypeScript wouldn't let me do that, because obviously I've got a const there. If I were to set foo to let, it would infer the type, but this time it would just be a string. So you can see the inference is very, very clever. It's not just working in black and white absolute terms. It knows about the flow of our program. It understands JavaScript really, really well. So it's able to do really advanced things with its inference. However, there are still cases where it's just not possible for it to infer, based on the code that we've written, exactly what the type should be. But it doesn't just throw its hands up and complain and say, I can't deal with this, you have to do something. By default, it just lets you get away with it. It just has this type called any behind the scenes. And so that is what A would be here, and that is what B would be. You can see the type is here. The parameter B is of type any. Now, the only difference here is that because we've enabled strict mode, we've now set, effectively, the compiler flag no implicit any to true behind the scenes as well. Whereas before, we didn't have this enabled. This is false by default. And as the name suggests, no implicit any simply means we're trying to catch any case where the TypeScript compiler has had to say, I don't know, this could be anything. So the most basic way to fix this is to explicitly mark it as any. As you can see now, the difference between A and B is purely that I've added a type annotation. They're both still of exactly the same type, which is any, but this one is explicitly any, and this one is implicitly any. And the idea being that if I've taken the time to mark this as any, I've clearly at least understood that this should be of any type. By not allowing implicit any's like that, we're guarding ourselves against the case where TypeScript has created an any type behind the scenes because it couldn't work it out, but maybe we weren't even conscious of that. Maybe we have some convoluted code which TypeScript can't process, and it has to infer type of any, but we didn't even realize that it was doing that. We thought for some reason it could infer it. So forcing us to write explicit any's in cases like this is really, really useful. So this is not something you'll need to do an awful lot of, because as I say, the inference is really, really good in TypeScript. But that's an example, just easy to highlight, basically. I've got a couple of examples highlighted by this one method. So that's why I started with no implicit any. So naturally, with an add method where we're taking A and adding it to B, we don't want it to be anything really. We know that it's going to be a number. So if we add type number here, it's a much more accurate picture of what we're doing. But what I'm going to do now that I've changed this method signature is I'm actually going to go back and I'm going to disable strict mode again, just to highlight another one of these flags. I'm going to reload the TypeScript project. You can see my squiggly lines have gone away again. And I'm going to use the add function now inside of this here. And I'm going to add 1 and the string of true. So because we added our protection of our number type here, we are catching the case where we're passing in the wrong type of parameter. So we can fix that by making it 1 and 2. But imagine a really common case if we're invoking a function and the thing that we're passing in is undefined, or maybe null if we set it to null. So let's say we're passing in undefined and null now. So again, we've disabled strict mode. So we're now back to a case, we're now back to the situation that you get out of the box with the Angular CLI. Strict mode is disabled. So if I wrote this code in the default Angular project, this would still type check correctly. There's no errors here by saying this add undefined and null. Obviously, if we try and add undefined and null, it's not going to be pretty. So this is something that ideally we'd like the tooling to catch for us. And it's quite unintuitive that it doesn't already catch it for us, because you would think surely undefined and null would be caught here. But the reason is because historically, undefined and null were actually subtypes of every other type in the system. So when you write that something is a number or something is a string, you're actually saying it could be a string or undefined. That was essentially the case for everything before TypeScript 2.0 introduced the concept of strict null checks, which is another one of these flags that is going to be turned on when we enable strict mode. So just to focus on that, I'm going to enable just that flag by itself. Strict null checks. True. Component. So now you can see undefined is being flagged. Argument of type number is not assignable to parameter of type number. So before, undefined was assignable to a parameter of type number. It no longer is. So when we catch the undefined, we can replace that with a valid example. The same thing happens with the null. Null and undefined are now their own distinct types with that strict null checks flag enabled. So that means they're distinct from strings and numbers and all that booleans and all that kind of stuff, but they're also distinct from one another. If we were to say var bar is of type undefined and we set it to null, this wouldn't work because null and undefined are not assignable to each other as well. So we now get very strong guarantees about our use of undefined and null in our programs, which is really, really useful. So that's our example of add, and we kind of cleaned up that code now. We've not really, we've not had to add very much. All we've done is added our correct types because they were previously being inferred to be anything. And we've just highlighted an example of strict null checks. Another example of strict null checks is actually already visible on this page. It's our use of the DOM here. So before, this is quite an interesting case of how enabling strict null checks actually changes the types that TypeScript gives you out of the box. So just reload this again. Document.getElementMyId. Very, very common DOM method that we use to retrieve something from the DOM by a particular HTML identifier. So here we're grabbing it by title. So document.getElementById in Visual Studio Code, for example, but in most IDEs that support TypeScript, we can hover over and we can see the signature of the function. So we can see that it takes in an element ID, which is a string, and it returns an HTML element. That's the return type of the function. So therefore, the type inference can work nicely, and title L here is an HTML element. All good. So on a title element, we have the method addEventListener, because that exists on that interface. We can say, we can use that method. We get autocomplete. We can see the signature. It's really, really cool, really powerful. However, this is not a true reflection of the return type of getElementById, because what happens if the ID doesn't exist in the DOM when we actually come to run this, not when we compile it? GetElementById won't return an HTML element. It will return null because you can't find the element. So the true type of title L should really be HTML element or null, because the return signature of this built-in type that TypeScript gives us should be HTML element or null. So as you might have guessed, if I enable strict null checks, that's exactly what happens. So I'll return this to title. Title L is now HTML element or null. The type has been widened, as it's described. The return type of this function, this method, getElementById, has been widened. Therefore, the inference has been widened. And that means when we come to use it here, we no longer have any guarantee that we have an addEventListener method available to us, because null doesn't have an addEventListener method available on it. So we have to do something about this code here. Now, TypeScript has what's called control flow analysis built in, which just is a fancy way of saying that it's able to analyze the flow of our program, things like switch statements, ifs, elses, that kind of stuff, and it can understand how those things affect the types in our programs. So what's a logical way that we could ensure that this doesn't break at runtime? We could add a check that title L is not going to be null. So we could add a very basic one that just checks if it's truthy, because title L, if it was null, would be falsy. So just doing this, make sure that we protect against the case where it's null. We wouldn't enter this if block. And as you can see, the red squiggly line has gone away, because at this point, title L is a wide type of HTML element or null. It's a union type. But inside of the block, title L has had its type narrowed to just HTML element. TypeScript is smart enough to figure out the meaning of if, and it's the meaning that gets reflected onto the types. So this is a narrower type, and we get no error, and we get code completion, exactly what we would expect. So this is really, really powerful. It doesn't matter how you write your code. If you write in a defensive style, so if I were to do if not return blah, 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 TypeScript can pick up on that, no problem. It understands the control flow analysis. It understands the repercussions of our JavaScript, no matter how we write it. Cool. So
I just want to add in, I love that feature, the ability to not just define what the type of a value is or of a property, but also that it basically interprets your application and knows the flow of how it's going through to be able to change the type based off of the code that you write within there. It's absolutely amazing. Yeah, it's so cool.
And I have to tell you, I wish you could see the people while you're talking, because everybody's like randomly nodding while you're talking. So it must. I've already learned like 5 new things that I didn't know, and I write this stuff every day. So
awesome, perfect. So there, just to use this example though, there is another feature in TypeScript. It doesn't apply to this particular case. Well, actually, you could say it does. Actually, to be fair, if you decided I'm 100% confident. I mean, I wouldn't recommend this. I would recommend this style, that you actually write a runtime JavaScript check for protecting yourself against a runtime issue. But you could say that I am 100% confident that this title will exist when I want to look it up at runtime. Therefore, screw you, TypeScript. I know better. Don't tell me that this is wrong. You can override TypeScript here, and you can use what's called the non-null assertion operator. Sexy, concise name. And you can say that this is not null. It's not going to be null at this point. And the non-null assertion operator is an exclamation mark. So right after the name here, before the property access of the dot, if I add an exclamation mark, then I declare to TypeScript, this is not null at this point. And so the error has gone away. That's a feature that exists because there are valid use cases where TypeScript won't correctly be able to narrow the type from null or the thing, and you can declare, no, it definitely isn't null or undefined. It is the thing that I want it to be. As I say, I wouldn't recommend DOM lookup as one of those cases because it's just trivial to write the check. Just protect yourself at runtime as well. But here you can override the type that TypeScript would otherwise be saying of HTML element or null. And this works for undefined as well. So non-null assertion operator doesn't just mean it works on null types. It also works on undefined types as well. You can say it's definitely not undefined. So just to show you that, I could do var x. Yeah, what could I do? Var x undefined. No, var x number equals undefined. This makes no sense, obviously. I've said x is a number, and then I've set it to undefined. But I could declare that undefined is not undefined by adding an exclamation mark. This is obviously nonsense code, but it just shows the fact that undefined type, which is being taken from the value undefined, you can override it and say, nah, TypeScript, trust me. I like to think about it. I always remember the exclamation mark because it's like you're shouting at the TypeScript compiler, no, I know better. So that's how I always remember it. It's definitely title L. That's how you remember it. I can't see anybody's faces. I hope everyone's enjoying my hilarious sense of humor.
Yeah.
Quite late.
It's actually funny because here in Houston, we can see the Hangouts chat, and our panelists are not used to that, so they're just they're talking about how they love it when you say "screw you, TypeScript," and everybody got a kick out of that. And now we can see it. Yeah, we love you. Keep going.
I hope that doesn't become a meme.
No, it's fine.
So similar to using the exclamation point, like another approach that I've used in the past, and maybe you can tell me that I've been doing something wrong, is if I didn't have just one use of title L, let's say there were 5 different things I wanted to do with it at once, I in the past have done things like casting the title L to the HTML element. Like you could cast it to an any, of course, but in this case, let's say I know that it's an HTML element, that it's not undefined. So at the end of line 16, I could just say as HTML element, and then I wouldn't need the bang.
Yeah.
See, I was thinking you would put const title L and then colon HTML element right there.
Yeah, so I can write that out as an example. So here, it's often called a typecast. It's technically in TypeScript, it's called a type assertion. This is the type assertion operator. Another way of writing type assertions is using the angle bracket syntax. So that's exactly the same thing twice, basically. You can either do this or as. The reason they both exist is because this looks like a JSX element. And so for ambiguity in React, for example, you can't write this. It would think it's it's a JSX element, so you have to write as. But that's an aside. So doing this is a type assertion. And the only reason I pick up on that name is because remembering it's called a type assertion helps you remember exactly what you're doing in this situation. This is very, very similar in nature to the non-null assertion operator. You are asserting to the TypeScript compiler that you know better than it does. So that's why this works, because I'm asserting to the TypeScript compiler, you think it's HTML element or null, but you're wrong. So I would say you need to be very careful with type assertions or casting. I mean, people call it casting, so I think it's perfectly fine. But that's a reason to be careful with it, is because you are relinquishing or you're giving up the advantage of having the TypeScript compiler because you're just overriding what it thinks. So it's the same thing as doing this. So in that way, it's no worse. This is just a new feature which allows you to change specific cases of null and undefined to not be null or undefined. But this is the same effect. So to answer your question about whether you're doing it wrong, it's just the same thing basically, as you're taking the responsibility of saying you know better than TypeScript compiler. So even though in this particular case I can say with relatively high certainty title will exist because I have good oversight of all the different moving parts, even in this scenario, I like to put a check. I like to write defensively. I just do. So that arguably that's personal preference in this case, but yeah, I think remembering the things called the type assertion is quite useful for reminding yourself that you're asserting this is the case. It's not taking it into account or anything like that. You're just telling it flat out. This is how it works.
Yeah, I actually turned on Strict today for part of one of our smaller apps, and I had this exact debate with myself between these two options.
Right.
And then I ended up doing something that was safer anyway, and putting in an explicit check before that just to be safe, because I realized that either way, it wasn't truly safe, and that I could be running into a potential problem. I didn't know 100%.
Yeah, exactly.
I have two things. First of all, my one takeaway is that I now have heard James Henry say that he is smarter than the TypeScript compiler, which is a brilliant takeaway from this, and I'm happy to have heard that. The other thing is something that Bonnie
no context to it at all. Love it.
Oh, that's fine. It's tweetable. So if you can remove what you have highlighted there on line 16.
Yeah.
And
I'll remove it. Sorry.
Yes, please. And then at the end of the declaration of const L, if you were to put, define the type there as : HTML element, and then remove the exclamation on the, well, it shows it there. Yeah, that's what you had brought up on it. But just to point out that what's being returned from get element ID is either HTML element or null. So the types don't match up at that point, which is why you need the assertion beforehand.
Yeah, exactly.
I totally knew that, Brocky.
And the reason is because the whole of the type is not being accounted for. As you can see in the error message, type null is not assignable to HTML element. So we could write out the same type again if we wanted to. This would be a valid assignment because we've accounted for the full type that's being returned. And then obviously we'd have the same problem about this being possibly null. But yeah, we can't use this. You can't use the type annotation as a way to assert the type. That's why we need the other syntax available to us to either do this or HTML element as HTML element. Sorry.
And again, that's because you have the strict null check.
Yeah, exactly, exactly. So if I didn't have strict null checks on, the null type concept doesn't even exist. So I could, in this world, have this reload project. So now this return type is HTML element, and there's no null accounted for. So this is valid at the moment. If I were to enable strict null checks, then this would now fail. So yeah, enabling this in your projects, particularly if you've been going for a while and written a lot of code, will flag up new issues for you. But as you can see in cases like this, it's a very good thing because it's potentially a class of runtime bugs which you might not have covered in unit tests, which you just catch for free when TypeScript runs in strict mode, in strict null check mode.
One problem I ran into today while I was doing this, it was with a third-party library that will go unnamed. The third-party library declared that the arguments that it took were only of a specific type and not undefined. But I had a situation where I didn't know what to pass in, and without the strict on, I passed in undefined and it was fine. But I looked at their example, and their example said pass in undefined when you're in that situation, but their actual typing didn't allow it.
Right.
I had to dig into their code to find out what they actually wanted me to pass in for that case, and it turned out to just be an empty object. But I had no idea because they didn't document what they wanted for that situation in a way that matched their typing.
So that in those kind of cases, you can work around incorrect type information with the non-null assertion operator. You could have said TypeScript, don't worry about this being undefined. You could have done that, for example. Or in worst case scenarios, you can assert that it's type any. That's the worst case scenario, but they're pretty much the same. In both cases, you're saying you're sneakily getting away with the type information not matching because you realize the reason for the type information not matching is that the type information provided for by the library doesn't match its runtime semantics. So that's a perfectly reasonable, that's a good reason why this backdoor, if you like, or this escape hatch exists, so that we can get out of those cases. The TypeScript team has never tried to reinvent JavaScript. It's always just tried to come up with the best tooling that embraces how crazy dynamic JavaScript is. and try to support any kind of legacy library in any way through its type system. So it's really, really cool. Cool. So that
Hey,
one.
James, I think Justin had a question too.
Okay.
Or a comment.
Yeah. James, one of the things that I really like about this and turning this on is it forces you to deal with those scenarios and think about, like, how would you want your API, your code, your UI to handle the case where that's possible, right? Where that get element by ID comes back null. What is your program, your software going to do if that happens to be the case? And we get into that very easily as we start passing in dynamic data through there. And also we can find ourselves in the case where an end user does that at runtime. And now we've had to ahead of time program and around being prepared for that, which is nice.
Yeah, exactly.
And
It changes your thinking, even when you don't have strict null. For example, if you move to another project and they don't have it enabled, I've often found it's changed my thinking so much that I'm writing code as if it were enabled, even though it isn't. I think it's a great point. Like, it makes you think about those problems, which you should have been thinking about really the whole time. But yeah, it's a great point.
And if you ever have anybody on your team who really just doesn't like, just turn it off because it's too much trouble, then you should assign them for a whole month to fix bugs. And then they'll learn.
Yeah, exactly.
Don't ask me how I know that.
So that's another class of issue that we've dealt with there. So I'm just gonna do this. I'll go back to here, back to our agenda. So we've looked at always strict. We've looked at no implicit any. We've looked at strict null checks. So we've still got no implicit this and strict property initialization to look at in this session. So these won't take very long. So I've turned back on the strict mode, and so we've got two more issues to look at in here inside of this component. So the first one we're going to look at is strict property initialization. And as you might be able to guess from the name, this concerns how we initialize our properties. So in this particular case, we have a property on our component called name, and we've said it's a string. However, we've not given it any value when we initialize it here on the class. So it's a bit strange that we're claiming it's a string, but we haven't set it to any string here. Because in JavaScript, when we don't set a value, we're implicitly saying that it's undefined. So property name has no initializer and is not definitely assigned in the constructor. It's a modern feature in TypeScript, so it's got a very good error message. It's telling you the two scenarios you can do this in which are valid, and we've not made use of either of them. So we can fix this in two different ways. We can either do name as a string, and we can set some string, and then obviously this is valid because we've initialized the property immediately. Or we can also do the same thing inside of the constructor. TypeScript lets you do this. This name equals string. This is now valid as well, because this counts as still the initialization phase of the class. So particularly relevant in an Angular context where we have this concept of a life cycle that Angular overlays on top of the semantics of a class. We are making use of one of them here, the ngOnInit lifecycle hook. This will be called by the framework, and it will execute the method, and whatever we've got in here will be run. So you could imagine a case where you don't need any you've not got any dependency injection or whatever, so you don't have a constructor. So rather than introducing a constructor just to set the name, you might be doing something in your ngOnInit which involves setting the name. So naturally, TypeScript doesn't really care that Angular's got this life cycle. It's not going to include it in its cases of the life cycle of this class. So it doesn't really have any meaning that we've assigned name to a string at this point. This is still too late. But we can, again, make use of the special exclamation mark character to override this strict property initialization feature. So if we are confident enough, again, it's us yelling at the TypeScript compiler that we know better than it, we can say, I know I'm going to be initializing name to something, so TypeScript, don't worry about it. And I can say, I can put an exclamation mark next to name, and this will, all it's doing is just telling the TypeScript compiler to shut up, to not give me the error. It's not fixing the error as such, but it's just saying, TypeScript, I know you can't work out what I'm doing here, but trust me, it's good enough for this use case. So that's what I've done here. So in this particular case, for example, if this was an input or something like that, where I'm providing a fallback value if it's not set, I would definitely always favor setting the value as soon as possible. And usually as soon as possible, especially for a default value, is when you declare it on the class. So that's definitely what I would recommend. Quite a common thing I see, which doesn't necessarily have too much to do with strict property initialization. But for example, if people are using ngRx, they'll often do something like this. And obviously store doesn't exist, but if they hook up their selectors inside of the constructor like this, and they're doing this dot my stream whatever strem, and they're grabbing something from their store. Oh god, are they grabbing something from their store? They'll often do this, whereas store is already available to us in the initialization phase. Once it's been injected like this, once we make use of private, it's available to us. So we can just have that in line because we're already erroring here because my strem has not been declared on the class. So we can declare property with the TypeScript compiler's help there. But instead of this step of doing it like this, we could have just done this directly in line. So then all we need is the constructor for dependency injection reasons. We can save some lines of code, or rather we can save some indirection where we have to first look up my strem has been declared, then we have to look up where it was assigned. But here we can see it's declared, initialized, all in one place. So that's a bit of an aside. It's not really directly relevant, but I think it's a good use case for just making sure you initialize your properties as soon as possible, really. It helps with readability, in my opinion.
I've never considered doing that. That's pretty cool.
Yeah, it doesn't, obviously, it's not specific to ngRx store. It applies to anything you pass into the constructor, which is available. If you've got like my collection, which is coming from my service, get collection or whatever, if it's a static collection, oh my God. If it's a static collection, then if my service was injected here, okay, we're not talking about this feature in TypeScript, but I may as well cover it. So if this was of type my service, and I was injecting that, you can see I've got my service injected here, but it's still erroring up here. And that's because there's a special meaning to when we say private or public on these things in TypeScript. It's doing two things. It's both setting the accessibility modifier, making sure that we can access it everywhere or just within the class, but it's also creating a property of the same name on the class automatically for us. So what my service here is doing is it's just injecting the value into our constructor. So I could say my service in here, that wouldn't be a problem. It's defined in here. But this .myService is not being created for us. This .myService equals my service is what we'd have to do if so we'd have to declare my service up here separately, then we'd have to assign it in here. TypeScript handles all of that automatically behind the scenes when we use its accessibility modifiers. So when we say private, we're declaring a property store behind the scenes automatically. We're also setting it to the thing that's being passed in automatically in the constructor. So that's why that's always magically worked for you if you've never seen the accessibility modifiers in any great depth. So all I need to do to get this to be added is add private or public, and then this will be added to my class automatically. But if I don't have that accessibility modifier, it never gets added. So yeah, so I'm not going to deviate any more than that. But that's I think that's a feature that I've often found that people haven't realized is happening behind the scenes. They're so used to writing private, my injectable thing. They don't realize that's actually happening behind the scenes.
I have a question. But first of all, another quick statement is that, yes, private and public are most common, but there's also protected, which is available to that class and anything that inherits or extends that class.
Yep.
I just came across that last week in code that I was reformatting, and I never heard of that before.
Yeah. My other question is, what's the order of operation there in terms of defining what you have on line 13 versus setting it within the constructor code? Which of those would fire first if you were to possibly run into some sort of initialization for each condition?
Well, I think it's all synchronous and at the same time, I guess. I honestly don't think there could be. There's no way they'd be happening at slightly different micro tasks or anything like that. I honestly don't think it would be possible to have race conditions in there because you couldn't be dealing with any kind of asynchrony of any kind because it's just initialization of values. So,
okay,
I think it's impossible.
Just out of curiosity, what would happen if you put something else in? You put mystrem inside the constructor and defined it as something else.
I'm going to change this to stream just so it's easier to think about. If I put this in the constructor and define it and set it to something else, is that what you said?
Just curious because of Mike's question. It's Mike's fault. Mike started it.
So I could happily set this to something else as long as the type matched the inferred type of this. So because I've made this up, I haven't got any inferred type. It's just any. So I could put anything here. But if you tried this with real code, you'd have to have something which was the return type of your select function in here. So the type information is already there. In terms of the value that would get set, I imagine the constructor would take priority in that case. But I honestly can't tell you for sure. I've never tried it. It's a good question.
What's really cool about it is that the transpiled JavaScript has all the answers for us, right? Like if you were to look at this transpiled JS file, you would see what it wrote out to do in JavaScript.
That's true, actually. It's not relevant because there's no concept of a class property in JavaScript. Justin's just given us the answer. The constructor gets written to JavaScript, but there is no concept of a class property here. This.myStream is all that gets written to the JavaScript inside the constructor function.
See, we have the smartest panelists.
Yeah.
Those panelists over at Angular Air are a bunch of goofballs, but we have really smart panelists here.
This isn't Angular Air?
Hey, I got another question for you, James, while you're in here. Because I think this is something that I've come across before, which is inside that constructor that you got the private accessor, right?
Yeah.
But if inside of that constructor method, you try to use store without using this, I believe that it's going to let you do that.
Yeah, let you do that because it's just a value that is the parameter there, the argument in the function. So it's perfectly fine to use the parameter store.
And so it's you kind of get yourself in a weird scenario, right? Where you're like, okay, I wanted this to be this on this, and I kind of want to use it in that paradigm. But here in the constructor, I may use it as the parameter coming in just like that. And I've run into this where you start off with the constructor where you don't have the private accessor and you don't have that syntactic sugar going on to create the backing property. And then later you create another method and you're like, I need that. So I add the private so I could be on that class, right?
Right.
I don't update the constructor code and it gets kind of weird. I wonder if there's anything in TypeScript that can help kind of tell you about that. Does that make sense?
Yeah, I mean, other than just the erroring, for example, this wouldn't be an error, but this would because I've used it at least once with this, like you mentioned. So if you didn't have this usage at all at the top, then you would never have any errors from this. You could freely use these just as parameter values inside of here. If you never needed to use it bound to the component class at all. However, just because we do have this concept of lifecycle hooks and that kind of stuff in Angular, I almost never have anything inside of constructors. I try and keep them just as dependency injection hooks, if you like. And then I put any kind of initialization stuff in my ng on init. Obviously, that is just personal preference. But so I always end up having them bound because I never use them in the constructor. So I just, by default, I always type an access modifier. And I start with private, and I make it public if I absolutely have to, which is very rare. So yeah, I think personal preference and writing style. But as usual, anything that comes down to personal preference, just try and standardize across your teams, and then you'll all be better off. Even if individuals disagree, at least if the collective is consistent, then it's usually more efficient to read and write the code.
Yeah, it'd be cool though to have like a strict constructor access modifier, flag that you could turn on. And so if you put private store, then inside your constructor, if you tried to use store without using this .store, it would warn you.
I mean, I think there is a TS-lint rule for that already, to be honest. I think there is. But if there isn't, it would be something you could definitely write, because the information would be there to make that possible. Cool. So we dealt with our strict property initialization check. That's now no longer an issue in our code. The last one we wanted to talk about was no implicit this. So very, very similar to no implicit any. Oops. This is where the this binding, wherever we happen to be in our code, TypeScript can't infer that the type is anything other than type any. It can't be explicit about the type. We've not been explicit about the type, and it's had to infer that it could be anything. So in this particular case, I'm using some old school DOM stuff. So I'm adding an event listener manually, and inside of a function that you pass to a click handler here, to the click handler function that we're registering as an event listener, if we use this inside of here, it's got a special meaning in the DOM. It means that we're going to be pointing at the element that we registered the event listener on. This is not, as I say, not such a common pattern in Angular apps, because we've got other utilities inside of Angular to help us access DOM properties and register event listeners and that kind of stuff. But it's valid JavaScript, so it's worth considering. And it's a particular use case that makes sense to talk about implicit thises. So the this here, we've got the error. This implicitly has type any because it does not have a type annotation. So that's quite a clear error message. We know what the problem is, but how would you go about solving this? Because where would I add, like, how would I add a type annotation? So this is one of the few cases where TypeScript kind of had to come up with an unusual bit of changing the meaning of JavaScript a tiny bit, or like deviating slightly from it, just to give us the power to express the type information that we need. So handle click, obviously, the argument that we would get here would be the event of the click. So it's going to complain that it's implicitly any here. So I could just say event. So that's an accurate representation of what I would get here in this click handler. But TypeScript has got this special case where if the first parameter of the function is called this, it will be used as a special type annotation for the this binding inside of that function scope. So in this case, for example, we could start with the very basic solution, like we did at first with add, where we said A was any, B was any, to make it explicitly any. This is a way to solve the problem immediately, because we no longer got implicitly any for this. We now have explicitly any for this. So this is unusual. We've not changed anything about the JavaScript. This will still have event as its first parameter. But this is just a special case which TypeScript removes before it creates your JavaScript bundle at the end. But this is how you would type the this binding in a function. So here in this case, obviously this is the same as title L. So we could do HTML element if we wanted to. And this would be then type complete, like all the autocomplete and stuff like that. The type information can flow through more accurately there. But that's an example of implicit this, which can happen sometimes, particularly in fairly abstract code where you're writing a framework or something and things get passed around all over the place and TypeScript can't follow the logic, or it's very opaque, like in the case where the DOM has given it special meaning, like it's going to invoke handle click with this bound to the title L. We can't see that as developers. That happens internally. But we know it as JavaScript developers that this inside of a click handler function means the DOM element we're attaching it to. So this is a case where we can give TypeScript the information it couldn't otherwise have. Yeah, so that covers our final check that we were going to look at today. So I've kind of spoiled this already, but the last thing I wanted to talk to you about was how to avoid just a crazy, painful, big bang scenario where we come into our tsconfig in our Angular CLI project, which has got 1,000 components and all kinds of other code, and we do strict true, and we get 1,000 errors. So the way that we can do it is by pairing strict true with the other flags that it sets behind the scenes, and we can toggle the individual features on and off however we see fit. So for example, when I approach this with my clients, I immediately set strict to true, assess the the situation and then work out which flags are going to be most painful to fix the issues for, and I will just fundamentally turn those off. So for example, if the code base was littered with implicit any's all over the place, we could have strict true and just do no implicit any false. And this would give us all of the other checks enabled. So we'd have always strict true, no implicit this true, strict null checks true, strict property initialization true, but we wouldn't have implicit any turned on. So this is how you can get your project slowly but surely up to speed with the strict true flag. And you can do this. In some cases, for example, on large projects, I've literally gone strict true, and then I've turned off all of the flags that strict true sets, therefore negating strict true. But then I've worked out which flag would be the lowest hanging fruit, and I've just turned on that one. So I've got all of the options available to toggle as I see fit. I fix issue by issue, individual PRs, work up, and then the code base just improves then over time. Once the flags are set, the developers can't be contributing new issues because the build would fail, that kind of stuff. So this is a really good way, and the TypeScript team did a great job of thinking ahead about this kind of stuff to help you get it into your projects. And as I mentioned, what could also be the case, let's say you've done a great job, you've turned on the flags one by one, you fixed all the issues, you're now in a case where strict true, and let's say TypeScript 3 comes out. TypeScript 3 could introduce a brand new strict check called strict James bars, which forces all variables to have James in them somewhere. You might want to disable that, and you could do that. So that's probably quite common, that when new strict checks come along the line, you would want to initially disable them, and then do the same thing that you did when you introduced strict in the first place. You just gradually work through the issues. Once it's time to enable it, you don't even need to set it to true. You can just get rid of it because it's covered by the strict umbrella.
Is that strict James var actually a super secret TypeScript spoiler?
Yeah,
You heard it here first, guys.
I've got some dirt on the TypeScript team, so I'm forcing them to add that feature.
I think you should have gone for strict Mr. James, but...
Oh, yeah, damn. I need you to be my script writer, Brocky. That's the problem.
No problem. I'll invoice you.
Yeah, so that's what I had for today. So hopefully that was valuable. And if there are any follow-up questions, that was great that people were asking questions as we went along. But that was it for today.
I think that was awesome because I didn't even realize, like, I do this every day, and there were some things in there that I really think after today, every time I see one of those blasted red squiggly lines, I'm just going to go ahead and put the exclamation mark in there just to see if I can get away with it. I mean, like, screw you, TypeScript, do what I said.
What have I done?
Well, that was awesome. Thanks. Let's hear it for James Henry, you guys. I just have to say thank you so much for coming and teaching us cool stuff, because this was really a good session. I liked it a lot. Do we have any more? We don't have questions.
It's so dark here now. It looks like the light is going completely around me.
That's okay. It's dark. It's very mysterious.
Could you see me
lost
while
your
I was
vignette. Huh?
Could you see me while I was presenting?
No.
Okay, cool. Yeah, I was thinking nobody was pointing out that it was getting darker and darker in the room.
Well, it was bad when we first started because the light was behind me, so I was like totally in shadow, so you can only see my silhouette. But yeah, it's important for us to see you, not me. But yeah, that was awesome. Thank you very much. Any more? I think we're done with the panel. This panel has been really great. You guys are fun.
Yeah, that was awesome. Thank you.
And James, thank you very much for finally coming on ngHouston. That was really cool. We were really happy to have you, and you're always welcome back anytime if you want to come and teach us more cool stuff next time. Just
awesome.
Let me know.
Thank you.
All right, that's it. Thanks, everybody.
Cool. Thanks, everybody.
Thanks.